China's J-20 and J-35 stealth fighters are growing at a speed no one expected, and behind them is one massive advantage reshaping global aviation, an industrial engine that produces advanced aircraft at remarkable scale. With hundreds of J-20s already flying and the J-35 accelerating into serial production, China has built a system designed for rapid output, constant upgrades, and non-stop expansion. This is the real story behind their rising stealth power. China's high-speed stealth production machine. China's J-20 Mighty Dragon program has undergone one of the fastest expansions in modern aviation history. When the aircraft first took flight in 2011, it was considered a technological milestone. A decade later, it became something much bigger, a symbol of China's industrial acceleration. Today, China celebrates the J-20 surpassing 300 aircraft delivered, marking the largest fifth-generation fleet outside any earlier established producer. The core advantage is scale. China's production rate is estimated between 100 and 120 J-20s per year, a pace rarely seen in the stealth aircraft world. This rate is not driven by temporary surges. It is part of a long-term industrial strategy. Each year adds a new batch of fighters, expanding operational brigades and enabling nationwide deployment. The J-20 itself reflects the benefits of this rapid production cycle. It features a canard delta design, internal weapons bays, and a blend of long-range performance with advanced low-observable shaping. Internal tanks allow travel of approximately 1,100 nautical miles, supporting extended missions without external tanks. China reports a top speed of Mach 2.55, while a ceiling near 65,000 feet gives the aircraft wide vertical operational flexibility. Engine development highlights how production speed is reinforcing technological progress. Early J-20s relied on imported or interim engines, but newer units are powered by domestic options. The WS-10 afterburning engine, producing around 30,000 pounds of thrust, is already deployed. Even more significant, China claims production of the WS-15, a next-generation engine designed for better acceleration, temperature tolerance, and sustained performance. This cumulative effect, steady industrial output plus iterative refinement, creates a unique momentum. China is not only building many aircraft, it is integrating improvements with each batch. Continuous production ensures fresh components, updated avionics, and enhanced manufacturing techniques. The J-20's expansion is therefore not only about size, but about the ability to keep upgrading, testing, refining, and distributing new capabilities at scale. While the J-20 dominates China's land-based stealth capability, the J-35 represents the next phase of expansion, bringing low observable performance to China's rapidly growing aircraft carrier fleet. The J-35 program builds upon lessons from the FC-31 prototype, which first flew in 2012. Over a decade of refinement transformed the early design into a sophisticated naval aircraft optimized for high-tempo carrier operations. The J-35 incorporates folding wings, robust landing gear, and reinforced structures designed to withstand catapult launches and deck landings. These features align with China's new carrier technology, including electromagnetic catapult systems. Such launch systems reduce structural strain and enable heavier takeoff loads, allowing the J-35 to operate more effectively in maritime environments. Production numbers, though still maturing, demonstrate clear momentum. More than 57 J-35 units have already been produced, with annual output estimated between 70 and 100 aircraft. This places the program on a consistent growth trajectory similar to the early J-20 expansion curve. As new carriers join the fleet, production can scale further to supply both naval and land-based variants. The J-35 uses a tailplane configuration closer to modern multi-role stealth aircraft, balancing maneuverability, low observability, and strike capabilities. China's state-linked research institutes highlight its ability to perform multi-domain coordination, functioning not only as a fighter, but also as a sensor and communication bridge. According to Wang Yongqing, a chief researcher at the Shenyang Aircraft Design and Research Institute, the aircraft can detect targets, transmit their coordinates to other systems, and even guide external platforms using its onboard radar. This reflects a future where the J-35 is more than a carrier fighter. It is a connective platform within a broader naval aviation network. Its expanding numbers allow more carrier decks to operate stealth aircraft simultaneously, enhancing coverage and flexibility across maritime zones. But the most important element remains the same as the J-20, production scale. China is not building prototypes. It is building fleets. The J-35 is entering serial production at a pace designed for long-term deployment, training scalability, and rapid fleet modernization. Both the J-20 and J-35 share many technological features: stealth shaping, secure communication systems, expanding sensor suites, but their true power comes from something far larger than the airframes themselves. Their decisive advantage is production capacity, a long-term capability shaping the entire trajectory of China's aviation development. This scaling advantage stems from three interconnected factors. 1. Continuous production rather than incremental batches. China operates its stealth aircraft lines as ongoing, high-volume programs rather than small-batch specialty production. This creates several benefits. Workforces gain permanent expertise. Suppliers receive consistent demand, prompting high-quality output. Upgrades can be integrated gradually without pausing manufacturing. Testing feedback cycles become faster because new aircraft roll off the line every year. When hundreds of aircraft share similar production timelines, updates become easier to distribute, and training structures grow harmoniously alongside fleet expansion. 2. Industrial planning built for iteration and growth. Every new year of J-20 or J-35 production incorporates refinements, stronger materials, improved avionics, updated engines, or better heat-resistant coatings. Because new units are always in production, improvements do not have to wait for next-generation designs. They can be added instantly. This creates a rolling upgrade ecosystem where the fleet becomes more capable with each batch. 3. Supporting infrastructure scales alongside the jets. Large fleets require maintenance hangars, spare part warehouses, pilot training pipelines, simulator networks, engine testing facilities, ground support vehicles, data integration systems. Production scale forces all these elements to expand simultaneously. The result is a unified ecosystem rather than isolated aircraft. 4. Carrier aviation capacity expands in parallel. As new carriers like the Fujian join the fleet with electromagnetic catapults, the demand for J-35 fighters increases. Production scaling ensures each carrier can receive modern aircraft on time, enabling higher sortie rates, greater deck uniformity, more advanced training operations. 5. Strategic depth through fleet size. Large production numbers allow more training squadrons, wider geographic distribution, greater resilience, faster adoption of new technologies. The massive advantage is not a single aircraft specification. It's the entire manufacturing ecosystem that steadily produces, upgrades, supports, and scales advanced stealth jets. China's J-20 and J-35 programs reveal the power of large-scale industrial capability. Their massive advantage is not a secret sensor or an undisclosed performance metric. It is the sheer speed and consistency of production. With more than 300 J-20s built and J-35 output accelerating, China has created a system designed to manufacture, update, and support advanced stealth aircraft in significant numbers. This capability transforms each fighter from a standalone asset into part of a rapidly expanding ecosystem. As the production lines continue operating at high tempo, China's aviation landscape is evolving at a pace that will shape future training, carrier operations, and long-term modernization. The scale itself is the story. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, spaceinews.com. Thank you for watching, and see you next time.